that the OT security space is taking up in India, and we are having both sides, the bodies which are taking it forward through trainings, and the people, they are also willing to learn something on the domain. So I'm in the 17th year of my experience now, and most of my part, you can say 15 plus year I spent in cybersecurity. And throughout this journey, I had learned a lot on cybersecurity, whether it's like offensive side, defensive side, critical infrastructures, industrial control system, IIoTs, and maybe web applications. I try to work on all of them some way or the other, either through my job role requirement or through learnings and all those things. So today I would be specifically talking about uh, the NIST framework's first function, which is identity function. And uh, the idea is to give a brief on the requirement when you're identifying, and then a brief on the threat modeling. And then at the end, we will be taking up the questions that you might have. So I'll just share my screen now, and then we will take it forward. Is it visible? Is my screen visible to you?
Yes, sir, it
Yes,
is
sir.
visible.
Yes,
All
yes, yes.
right. Yes. Okay. So quickly, yeah, Akshay, you had given a good brief, but again, yeah, I put up a customary slide. So maybe quickly. Yeah, I'm currently working at the Siemens Research as a senior key expert based out in Bangalore. Before that, I have worked with the National Technical Research Organization, NCIPC. Since most of you are working with the power sector, you might know this body very well. So I was one of the founding employee in the NCIPC since 2014 till 2019 February. Uh, as part of my voluntary contributions, I'm currently also leading the IIoT committee and the ISA, and recently started something called as OT Security Huddle. So I'm currently building a community of people who are enthusiasts about OT security and really want to share their knowledge with the public. Yeah, so having said that, this is just a first slide to give you a brief about what we have been talking in last few classes. You must have read about the NIST cybersecurity framework, and this has 5 spokes starting from the identification, then protection, detection, response, and recover. So we are currently in the first leg, and this NIST cybersecurity framework is one of the best frameworks that is available today to organize your cybersecurity program. Identification as such is basically understanding what are the assets that you are currently having in your environment. Once you identify them, then the next step is basically to understand which are the most important critical crown jewels currently available with you. Since you now understand what are the uh, assets that are most important for you to function, the immediate thing is to understand the threats and risks which could hamper your operations. And specifically, if you take the case of industrial control system, you must have by now read the Purdue model. And in the Purdue model, the assets which are at the level 0, they are the most critical assets. If something happens with them, then the whole operation can be disrupted. Then we identify the threats and finally understand the weaknesses of this. So this is just an overview. And in today's discussion, we will be learning the asset management in the power systems. Then we'll walk through the vulnerabilities and how to assess them. Finally, we understand how to manage the users, the overall life cycle of managing users. How do we implement the authentication authorization technologies? And finally, a brief about the threat model. So before this, the house rule, we will finish the content first, and then we will be taking the question at the end. Immediately after this, we'll get into the content. But before I begin, maybe I would like to hear about you or what your experience so far, how much did you learn, and what do you think it would be there in the identify function of the cybersecurity framework?
Sir,
Nice.
just to interfere you, uh, the participants are from various power sector companies. We cover all the segments of power sector, right from generation, transmission, distribution, and we have participants from the India's largest thermal power producers also, and some of the IPPs also, and transmission companies and distribution companies as well. So this is a just brief of the participants, sir. Uh, I would request if now you can take it from it. You're asking about the details, so I just
Yeah, thanks, Akshay. I just wanted to get a feeling of the people's experience so far. What do they think would be the next in the identity function? This would actually help me steer the conversation to take it maybe a little bit more technically, or maybe take it a bit lightly on just giving the overview of these important aspects of cybersecurity framework. Anybody want to speak out?
Sir, I'm Anil Malik, DGMC and I maintenance. Actually, I'm working mainly. We are working in DCS. Networking is just basic. We have only basic idea.
All right. Okay, so let's then get into the asset management aspect. So few months ago, I had written a small conversation on how to implement a cybersecurity framework. So you can consider the cybersecurity as building your personal home. So when you start with, you first need to identify a land. Then over this, you will be sourcing different kind of materials. And with the materials, you are really worried about the quality of these things. You really want to know what grade of bricks I will be using, what grade of cement I'll be using. And if I don't use
So,
those grades, so
uh,
sorry,
so,
sorry. Okay. So I was talking about the different components when you are building a home. And we are talking about the quality of each one of them to understand the risks which are there. Then you are really worried what kind of a steel you would be using. So these are basically the building blocks and components which are there. Similarly, in any cybersecurity management, you want to understand what are the assets which are there, which needs to be protected. And this starts with identification and enumeration of the asset. In each of the technological aspect or each of the industrial control system aspect, there are different things that you need to be careful of. Like in IT assets, generally, the asset are either the physical assets or the digital assets. The asset, which are basically the human assets, are not given that much of priority. But in industrial control system, specifically the power sectors, the knowledge is aggregated by the person who are operating the plant for so long or operating the substation for so long. So we really need to focus on not only the physical, but the digital and human assets as well. And this starts with enumerating them either through an active scan or a passive scan. The active scans can be, using a tool connecting to the network and then identifying the assets through some aggressive commands. Whereas the passive assets, they could be like reading through the network configurations and maybe out of band communication reading, reviewing the architecture diagrams, all those kind of things. So when you might at this point have the question in the mind, which is the best method to identify or enumerate the assets? So this is the question I get asked multiple times. And when I go to plant, I always see challenges with one method or the other. And either of these methods, or say neither of these methods is comprehensive. You really need a combination of both of them to enumerate your assets. Specifically in the case of legacy systems where the assets are not connected to the network, you would have challenges to identify them through active scans or passive scan alone. You would also require to do a walkthrough and then identify each of the assets which are not connected to your network. Yeah. So you can take an example of, let's say, in hydroelectric dam, you might really want to enumerate the things, and then you start with turbines, the control systems, the operators who are very important for you. Because when the operator goes away, it becomes very critical to have another person available with similar kind of skills, right? Yeah. So having said that about this enumeration of the assets, there are few important aspects of asset identification. Once you have done the asset enumeration, the next thing would be to create an inventory of those assets. And what would you include in the asset inventory is another challenge that you might face. Because if this is not clear to us when we are enumerating the asset, we might only capture half of the information. So having a template of the inventory is very important. And throughout my experiences, I've seen the organizations generally use different kind of templates. Some of them might focus on the annual maintenance contracts more. Someone might focus on the criticality more. Someone might focus on the type of asset itself. But if you see, the basic things that an asset inventory should have is the type of asset, the name of asset, where the asset is located, what kind of firmware is there, what kind of operating system it's running into, the dependencies of the assets, and also the configuration of the asset, whether it's a standalone device or it's in a redundancy mode, the IP addresses, the protocols that an asset is communicating on, who is responsible for that particular asset. Do we have an warranty available for the asset? Criticality of the asset. These are the basic element, but there could be other things as well, like do we have a license key for that particular asset? Because we just spoke about type of the asset. These are the digital assets, and specifically when you talk about industrial control system, there are applications that require specific licensing. So that kind of information is also important when you are creating an asset inventory. The next thing that is important is the management of the asset through this life cycle of the assets. Initially, when you procure the asset, then you maintain the asset, and finally you decommission it. These are three broad phases. Throughout this three different phases, you require to maintain them, review them, update them after each patching or each upgrade. All those information should go to an automated or integrated applications. I'm seeing more and more application coming in from the IT side being adopted on industrial control system as well, and they are really helpful to maintain the assets. Also, since I mentioned the review is very important, the quality of data is also very important. So whenever you are capturing this information, make sure that the quality is up to date for these assets. So there are a few challenges that we have discussed in the previous slide as well. One is specifically in the context of grid, the assets are unconnected. There may be substation which don't generally have end-to-end connection available, which can be used to enumerate the assets. So you really need to go to those substations and then enumerate the asset there. I visited a substation a few years ago, and most of the assets were still electromechanical over there. There was only one connection that was available to the grid. So in such cases, physically visiting the substation is very important to enumerate the assets which are there. Again, there are geographical difficulties. Generally, your substation in the transmission lines, they are in the remote locations. So reaching out to those locations is a big challenge. Sometimes you are cautious to touch these systems because they are OEM managed. So you have dependency of getting the information, and it's always a good thing to call them up, get the information out, and then use that information to enumerate your assets which are provided by a specific OEM. License information is very critical because the entities in power sectors are highly regulated, and meet the compliance is very important for them. Yeah, so we just discussed about the asset identification, enumeration, and asset inventory. Once you have identified the asset, the immediate next step is identifying the vulnerabilities into those assets. So I just see that somebody has raised a hand. Before I jump into the next section, do you want to ask the question?
Sir, please elaborate active and passive device. To me, I'm not
Okay.
clear.
Okay, fine. So, active and passive enumeration. Yes. So active enumeration basically means that you connect to the network and then you send some command on the network to identify what are the assets that are connected. Have you heard of the application called Nmap?
No, sir, no, sir.
Yeah. So there is this application called Nmap. It is short for network mapping. And in Nmap, you need to send some specific command with some switches, which will go into the network and do a reconnaissance scan to identify which all things are connected to the network. So in this particular case, you need to be in the same network where your system is connected, but the same information can also be taken out through a passive network, which basically means when you are having a switch in your environment, you can actually put a mirror port over there, and the mirror port will be giving you the communication. And through this communication data PCAP, you can take out this information and put into the tools which are available. The example of these kind of tool is either Clarity, Nozomi, Tenable OT. There are some free tool available by OT base. You put that network traffic into those tools, and they will be giving you the asset inventory which are there in that particular network. But why either of them is not complete is when you are doing the passive scan, you will be capturing the network traffic. And this network traffic, it only captured for the time uh, when you are having this network devices connected to the network. And it may be possible that one of the device that is connected to the network is not communicating during that time. And if it is not communicating, the information about that particular asset would not be captured. So in such case, we want to ensure that we use active scanning method. In active scanning method, we will be sending the command and it will go to all the different network ranges available in that particular network and identify the asset that are available in that particular network range. So this is the difference between the active and passive enumeration. Passive is you are not doing anything to the existing network, just reading out the traffic through either a network tab or a mirror port. Whereas in the active scan, you are connecting to the network and throwing the nmap command. So now, this are you clear about these two different terminology?
Yes, sir. Yes, sir. Thank you,
Yeah.
sir.
One more important aspect of active scan is when you do the active scan, it generates lots of traffic. And this traffic can actually flood your network devices. So you generally would avoid doing an active scan, but you will rely on a passive scan more. Okay. So let's go to the vulnerability assessment. So vulnerability is something that is weakness or flaw in system design. It could be either in the application, it could be in the system, or it could be in the network as well. Network vulnerabilities are generally because of the configurations that we have done in the network. And typically in industrial control systems, we see lots of network level vulnerabilities because we leave the configuration to the OEMs. We don't give them the requirement for a network configuration. We don't provide the network ranges. We don't give the hardening requirements. And the OEMs or system integrators, they take it in their hand and their focus is to finish the project and configure it the way they have been doing it so far. So it's very important when we have identified the assets, the next step is to do the vulnerability assessment of the infrastructure that we are having. So vulnerabilities are not limited to your assets itself, but also the policies and procedures as well. So you might say that, okay, I will give physical access to my substation, but my procedure is if somebody is coming up with two, three other guys, and I know that one person, so on the base of his declaration, I will give access to 3%. So this could be a procedural vulnerability because when you are giving physical access to 3%, whereas you know only one of them and you don't have explicit approval from somebody at the higher level, this can become an issue. Can give you some examples. I visited few plants last year, and at least three of them I have identified that once if we reach out to the plant, there would be a gate pass that is issued to us. And what happens is these guys will issue a gate pass for three of us, single gate pass. In one odd case, I have seen that he asked two of us to sit on the chair and then he has clicked the picture. And after this, he has issued a gate pass. So in such cases, what happens when you are returning back from the location, there is no audit available or accountability available who has left the premise and who are available back into the location itself. So this is a procedural gap or vulnerability that is there. In architecture or design level, we can have issues like putting a dual home system on networks which are designed for two different things. So uh, in in substations, you have one network which is talking to your protection relays and one network which is talking to your SCADA systems. And if you put a dual home with the server, then it is not a best practice because if one of the network gets compromised, the chances of the other network getting compromised are very high because you are communicating with the same system, which is actually providing dual home in one network. Configuration wise, if you see the network switches, there could be n number of possibilities of configuration issues. One of them is keeping the default username password available. It's very easy now. You just simply put, let's say if you're using a Siemens switch, you Google Escalence switch, what are the default credentials? You will be able to find it on the internet. And if you have the access, then there are issues that the attacker might also get it. I think by now you must have heard about the attack called Stuxnet. So in Stuxnet, what has happened is leaving apart the story of how the attackers have reached out to the network, they had done the lateral infection and finally reach out to something called as WinCC, which is a Siemens application. After reaching out to the system, which is having the WinCC application installed, what they have used is default credential of WinCC to log in into the application. Imagine if this default credentials would have been removed and they would have put their own credentials. The attack would not have been possible at all. They would not get the access to the engineering system and would not be able to change the ladder logic of the PLC. So these small gaps that are generally overlooked because the perception is since my system is in an air gap network, nobody is having access to my system. How would somebody reach there physically and then use the username and password to log in? Is a misconception. Typically in the power sector, when I go and see, specifically in substations, what I have found is the username and passwords are generally written either on the screen of the computer, sometimes in the register which is there. And in the worst case, I have seen that there is a whiteboard and they have written the username and password on the board. These are again example of policies and procedural vulnerabilities which are there. On physical security side, we have seen this one example, issuing gate pass to 2% with their pictures of both of them in single pass. Software side, there are n number of vulnerabilities that do exist. And cybersecurity is, since it's not a one-time game, vulnerabilities are scanned at point in time. These vulnerabilities are discovered every day. And every day, since we are having new and new threats coming, new and new type of application design, there are new threats that are coming every day.
Yeah. Chala.
So I hope you understood what vulnerability means. Let's move forward. So in vulnerability assessment, there is a number of things that you need to do. First thing is to define, identify, and classify what are the security vulnerabilities that you need to do with your control system and the network infrastructure. Then you need to evaluate the design of your system, their implementation, their configurations, and also their operations and management. You also need to identify the adequacy of security measures, and finally also need to know the known vulnerabilities which are there published by the OEMs and other vendors. Similar to either asset enumeration, vulnerabilities can also be identified either through active assessment or passive assessments. There is a more aggressive vulnerability assessment method, which is called penetration testing. But let's talk about first about the active and passive assessments. In a passive assessment, you discover the network devices using passive means, either reviewing the drawings, walkthrough of the plant, the substation, analyzing the network traffic, and analyzing the ARP tables. So this is a bit technical term. ARP tables are basically the tables generated by the network devices. And generally, when the systems do communicate at the layer 2 of the TCP IP stack, and they have this MAC address to IP address table, and systems do store it locally. So if you get access to this table, you would be able to see how many MAC addresses are there in that particular net. Another example of discovering the vulnerability using passive means is capturing the network traffic through network taps or uh, switch or router mirroring, reviewing the network configurations, and researching the vulnerability database as well. So let's say you have one particular device, and since you have created the asset inventory already, you know what is the make and model of that particular device. You also know the version of the firmware, which is already there. So you can go to NVD database and then search that particular model. It will give you the vulnerabilities that do exist in that particular model. Once you have done this, it helps you in understanding the system and the processes, and also helps in creating the update to the document. In active scanning, there is a need of using some scanning tools, but be cautious. Active scanning could be intrusive and it might fiddle with the operation of your control system. Nmap is one example where you will create some command, send it to the network, and then it will give you the system that are connected to that particular network. The other example is ping sweep, ARP scan. You can also do the same thing through Nmap, but there are other tools also available. There is something called a Shodan database. I hope you must have heard about Shodan by now. So Shodan is called Google for hackers, and the search engine was popular 15 years ago a lot, but today also if you go to this particular engine, then you would be able to see the vulnerabilities which are there into um, devices which are connected to the network. Then we have advanced tool like OpenVAS, Nessus, Nexpose. These tools are typically available open source. Nessus gives you a 7-day license if you are registering there for trial. OpenVAS is, the name itself says that it's an open tool. You can install with your Linux machine and then scan the network. Again, this active assessment will also give you understanding of the system and processes, and also help you upgrading your asset inventory when there is updated information available on the network. So there are a bunch of common configuration and other kind of issues that you might see when you do these assessments. In configuration management side, you will see hardware, firmware, software generally lack the configuration oversight. And sometimes when you have delay in patching your system, then you will also find this vulnerability in your system. And sometimes the OEM themselves will be delaying releasing the patch. Sometimes your process does not allow you to patch your system. So because of any of this reason, you might have vulnerabilities in your system. On testing and access control side, you might have inadequate or insufficient testing mechanism. And vulnerability assessment is also one kind of testing itself. Once you don't have this, then typically you'll find a number of vulnerabilities existing in your system. There could be other issues like you are giving somebody a weak remote access. Pretty often I see the applications like AnyDesk or TeamViewer being used to give a remote access to the vendors. And these applications not only come with their own issues, they are not secure methods to give remote access to maintenance engineers. Also, there could be failures to store the backups and protection of the configuration of the device, and this could be your procedural and policy vulnerability issue. On password policy side, sometimes the devices are left unprotected. They are generally open without any authentication control. There may be non-compliance to the password policy of the organization, and sometimes improper uh, access control may also be the vulnerability to your system. Then we have malware also as one of the vulnerability in the system. If your system is not having anti-malware installed into it, it's also one of the um, vulnerability that could exist there. Then denial of service is a very dicey stuff to control. You might have issues like not giving configuration level protection to your system. And if somebody flirts with a number of requests to your system, there might be denial of service. And finally, typically we don't have continuous monitoring implemented to our system. So this also could be one of the reason that we don't know what is the vulnerability that exists in our system. Penetration testing is an advanced scan. It starts with the active vulnerability assessment. And once you know that we are having these vulnerabilities, we try to exploit these vulnerabilities. It's basically knowing which is the weakest brick in the wall and then try to hammer it out to get access to the building. When we are doing the penetration testing, it's very important that we take the perspective of an hacker. But what would a hacker do to get inside our system? Penetration testing generally seeks to identify and take advantage of both known and undiscovered security vulnerabilities. So at this point, I would like to introduce a term called 0 days. 0 days basically means the weaknesses in the system which are currently not disclosed by the OEMs or the application providers, but the hackers do know about them, that they do exist. And if you take the biggest of the example of biggest of the biggest threats, there is generally 1 or 2 0 days vulnerabilities are involved into that. So penetration testing are advanced and they are also help us in evaluating the efficiency of the existing countermeasures that we might put. So in the first vulnerability assessment, we have identified what are the weaknesses that do exist. And then we will also put some security around it. Penetration testing actually help us how strong that security control is for that particular system. So now coming back to why we need to fix the vulnerabilities. It's very important to fix the vulnerabilities because when they get exploited, they violate the integrity or security policy of the systems. I just mentioned about 0 days. Stuxnet had 4 0 days involved into it. Then we have the Ukraine power grid attack. Though there was no malware use, but it has exploited the known vulnerabilities which were there in the system. Similarly, the water treatment plant in Oldsmar in 2021, it has also exploited the known vulnerability in the system. It did not require any specific.
Mute all the participants, please.
We request all the participants to kindly mute themselves. Only if there are some questions, they may raise hand and then ask from the faculty. Thank you.
I think I was also muted. Okay, so we started with the asset inventory. Then we had discussed the identification of vulnerabilities. So asset inventories has three different aspects: people, process, and technology. In vulnerability identification, we have initial level, passive, active, and penetration tests. Immediately after that comes the analysis of the risk, and risk involves threat, vulnerability, and the consequence. We will be talking about threat in the coming slides, but for now, let's focus on the vulnerability. Once we have identified the threat, vulnerability, and the consequence, the next step is to prioritize the risk, whether it's a high risk, medium risk, low risk, or insignificant risk. Based on that, we should design a remediation plan for our assets. Let's say it's a very critical risk. So the remediation plan should say we need to fix it immediately because there could be an eminent hacker who is looking for us to attack us immediately. Once the remediation is done, we need to really re-verify whether that vulnerability is patched or not patched. Sometimes there could be false positive. We report it, and this whole cycle needs to be repeated every time you discover a new vulnerability. Some organizations do put a cycle around it, maybe a quarterly cycle, maybe a 6-month cycle, or maybe a 1-year cycle. But for power sector, CEA has given a guideline. Earlier, it was a 6-month cycle. Now they had given the relaxation, and then every 1 year, you need to do a vulnerability assessment of your system. So these are few examples. Vulnerability assessment and management in power sector specifically is very dicey. Sometimes, typically, when you use these tools, the tools are borrowed from the IT industry for doing the vulnerability assessment. And they would give you some vulnerabilities like you see on the screen. The first vulnerability specifically talks about SSL vulnerabilities. SSLs are generally used for your browser level protection. When you are surfing a website, then SSLs are used to secure that communication through an encryption. Similarly, the second example is about using an NTP service in the system. When you are using an old system like Windows 7 or so, they have their own limitations. Like Windows 7 does not support SSL beyond SSL 2.0, while currently we are using TLS version 1.2, which is an advanced version of SSL. So in such cases, when you have identified the vulnerabilities, it becomes very important that you go back and check whether this vulnerability is relevant to your system or not. This vulnerability may be identified because the service which is there in the system is kept open, but never used. So what you could do best in such scenarios, you go back to the system and just disable that particular service rather than focusing too much on upgrading the system itself. So this is an patch management guideline from using the 62443 2-3 standard. And it talks specifically about gathering the information, monitoring the evaluation, and testing the patch, deploying the patch, and then finally verifying. I have specifically put this cycle to give the 62443 context because patch management is basically fixing the issues which are there, either on the security side or on the functionality side. Whenever you are doing the patch, this matrix which is given here is very important to design the responsibility of the people who are there, whether the engineers or the operators, each one should be involved to take a decision when to patch, what to patch, how to patch, and also update our asset inventory whenever we have patched a system and updated a firmware. So it's specifically in 62443 context. Previous slide, we are given the cycle. Here is starts with monitoring and identification of the patch, when you have the list of vulnerability, you go to the OEM site or maybe you subscribe one of their service. They will give you the information whether the patch exists for that particular vulnerability or not. You also decide the applicability. In the previous example of SSL, I just explained what applicability means. If you are not using the service, simply close that rather than bothering about upgrading the system. You do the risk assessment, take a decision, patch it, review the change, and then finally the risk gets mitigated. So this is the one graphic just from clarity. It says the top mitigation step, and first of them is the network segmentation itself. So most of the cases when you are doing the uh, vulnerability management, it get fixed by segmenting the network itself. You don't require anything else. The second next to it is putting a secure remote access solution. In your secure remote access solution, most of your vulnerability gets fixed. Finally, you can take a protection from the ransomware, because last 3 years ransomware is in news. Every now and then we hear a lot about ransomwares. So they are also very important to be fixed. Then traffic restrictions, user and their role policies. These are a bunch of things which are top 5 list. And the content of this today's discussion is also on those lines itself. So having said that, training is also a very important aspect, and we also need to focus on trainings when we are doing and updating all of these things, because patch and update is very critical. They might actually cause some disruptions. Training the people who are responsible is very important to understand how aggressive they can go, how to take the decision about patching and update. Yes, Deepak, you have a question?
Sir, please go to slide number 23, last slide. Sir, in patch testing, there is a one removal procedure patch for what is the reason of removal this required? Because
Okay.
qualification and verification is something, but
Yes.
removal procedure I don't know. Why
So
removal procedure required?
yes, so let's say you are patching a system, and after this patch, your system is not functioning the way it should have been functioning. What would you do in such case? You need to go back to the previous stage, right? Uh, the first thing that you would have learned in this course is how cybersecurity for IT is different from cybersecurity for OT is different from IT. You need to ensure availability of your system, right? You don't bother much about the patching. So removal procedure basically tells that if the patch is not allowing the system to function the way it's supposed to function, then we should also have a procedure to go back to the previous stage and remove the patch from the system.
But I think this one is so about the last patch, no, last patch removal procedure or
Yes,
new patch.
yes, exactly. You see,
Okay.
this headline is patch testing. So basically, you are
Hmm.
testing that particular patch which you want to do on the system.
Okay. Okay. Okay.
Yeah.
ठीक है. Okay, sir. Thank you. Thank you, sir.
Yes, Varun.
Hello, good evening, everyone. I just wanted to add a little bit what sir is saying, that normally this testing is done on the test bed. So we don't directly install a patch on the live system.
Yeah,
Yeah.
exactly.
Yes. Yes. Yes.
Thank you. Thank you.
Okay, yeah, so we have spoken about vulnerability. The next topic for us is user life cycle. Before I go ahead, do we have any question so far? All right. Yeah. So user life cycle basically involves how would you give access to your system to an user? And this includes identification of the user, authentication of the user, authorization of the user, and accountability of that particular user who is using the system. There are 4 distinctive things that are involved here. First, you'll create the user, then you assign some role to the user. Sometimes you need to change the role of the user. And finally, you the deactivation of the user. So identification basically means through what means you will identify a particular person who or a service that is accessing that particular system. A very typical example of this is the username. Whenever you are accessing a system, you first type your username and then you type your password. Password is an example of an authentication mechanism, right? So there are four things that are required for a user when he's accessing the system. First is identification, then the authentication of the user, authorizing the user, and also the accountability of the user. Now let's take an example that somebody wants to access a system. He will first type the username, then he will type the password, and finally he will get the access. But each of the system might have different requirement. When you are accessing your substation, there could be three different kind of roles that could be there. One is the operator, second is the engineer, and the third one could be either an administrator or a security analyst. In these three different cases, each of the user would have its own requirement for the system. An operator might not necessarily need access to the control panel of the system, or let's say D drive of the system, or say the command prompt of the system, or maybe the registry of the system. So for such cases, we require something called as authorization mechanism. Authorization mechanisms basically decides how much access you will be giving to a person to a particular system, right? So each of these four areas would have its own techniques. Let's first start with creating the user itself. So the procedure for user creation basically involves a step-by-step process of creating a user account, setting up their credential, and assigning them temporary roles. User creation also requires that we not only create the user in our system, but also ensure that they are having integration with the HR function as well as the administrative function. This is necessary to know whether the person is currently an active employee of the organization or they have left the organization. In historical attacks that has happened on the industrial control systems, there are instances where a person who got access to an ICS system, since they were not having integration with the HR function, they were not removed from the system. And since they were not removed, they knew a lot about the system, and then these informations are used for attacking the system. When you have the HR integration, when the person is either changing the role or he's moving out of the organization, you can basically put a checklist that whenever you are asking for a clearance, first go and check whether his credentials are removed from the system or the access to the system is removed. In ICS, the secure user creation is very critical because once you are having an access to the system, the criticality of that particular user to take action is very high. A person who is sitting in the substation as an operator, he can actually take the call to either shut down the substation or make some changes at the set points of the circuit breakers or their protection relays. So first method of giving access to the user is through role-based access control. And role-based access control basically talks about that you only give access to the level which is required for the person. So there could be four different roles that could be used. One of them is the system operator, then system engineer. There could be security analyst who is also accessing your system. And then there could be maintenance engineer. Maintenance engineers typically require this access through remote access as well. But if they are also at the site, there is a separate role and privilege list that needs to be created. Typically, these roles assignment are done through something called as user metrics. You create a user matrix, you put what kind of role are required for them, and then you assign it accordingly. So now on technology side, these things can be achieved either through Active Directory controller or a radius-based authentication. When you are giving the access to a system, Then Active Directory is used when you are giving access to a network device, then radius-based authentications are used. Coming back to authentication techniques, there are n number of techniques that are used. First one is basically the password-based authentication. You use your password, you define the strength and the minimum criteria that how complex your password should be. The other method is the two-factor authentication, like we use for our email access. There could be an SMS that is coming to your mobile. There could be an access token, or there could be an authenticated applications like Microsoft Authenticator or Ping ID, where you get the message or the PIN to enter in the system and get accessible. There are biometric authentication devices like fingerprint, face recognition, etc. Then we have access cards and tokens, which are typically used in ICS. We also have physical locks. They are used specifically to lock a specific function of controller. If you see in the safety PLCs, they do have these modes like um, program mode and run mode, which is typically done by a switch using a key. Then on the standard side, we have open authentication standard and then SAML standards. These are very, very technical terms, so I just put a name of these two different techniques that are used for authentication mechanisms. Authorization side, we have role-based access control, which is basically giving the access based on the user's role. Then we could have a policy-based access, which dynamically determines what privilege should be given to a particular user. We might also use attributes-based authentication. Then there is something called as privilege access management. This is typically designed for giving the access on higher privilege level access, let's say administrator or remote access user, these kind of roles. Then there are different tools that are available to manage these permissions. There are automated tools that can be used. One of them is Active Directory Domain Controller, radius-based authentication, but also to manage what kind of role is to be given to the person. There are other applications like ServiceNow that can be used to manage the credential. One very important topic for access control is to do regular audits and put strict permissions around the access control, because these are the first level of defense that you have for a user to get access to the system. So I have kept a specific example here for an architecture for giving remote access to an user. In this architecture, you see the remote user who is sitting here on the internet side. He will first get access to a VPN server in the corporate network. And from this VPN server, he will get access to something called as another VPN server or service PC in your control system LAN. Once he will get access to this particular VPN server here in your control system, then he will do RDP to the particular system that he wants to access on your control system or say substation or your control center. So if you give direct access to using a team viewer, then you basically are giving directly access to this particular area of your control system. And that is not a secure method. If anything goes wrong, there would be no accountability. There would not be a mitigation measure for the user. And it will become difficult for us to troubleshoot that particular um, system. I hope my cursor is visible. So I'm talking about this particular path from internet. You give access to the corporate VPN server, and from the corporate VPN server, you give access to something called a service PC or VPN server in the control system. And then from there, you can take a remote of the device that you want to give remote access to. Till this point, we had covered three topics. Now I'll be getting into the threat modeling. Before this, does anyone have any questions? Okay, let's move forward. So we discussed about identification of the asset, then identification of the vulnerability, then managing the user who are accessing the system. Now we want to understand the threats to our system. So threats identification basically help us in understanding the overall threat landscape that our system could have. What kind of threats are there for our system? It helps in identifying the risks. It actually guides our security investment. It also helps in compliance of the regulatory environment. And another thing that it could help is understanding what kind of approach you really want to take, whether a proactive approach you should take or a reactive approach you should take for mitigating your risk. And it helps in enhancing your incident management. And finally, it helps in building a security culture by embedding the threat modeling into the operation process of your overall environment. So there are n number of models that are available, and uh, first one is the high level threat modeling, which is also called as stride model. And this was given by Microsoft, and they also have designed a tool which can be used freely to model the threats. Then on the medium level side, there are MITRE ATT&CK frameworks available, and the low level side is the threat modeling specific to those vulnerabilities. So the common threats that we could see comes from three different areas, either on network side, the host side, or the application side. On the network side, somebody can actually spoof a packet. Spoofing basically means fiddling with the original packet, and the system will just think, okay, somebody legitimate user is sending the packet to us, but it is the malicious actor who is sending the traffic to the network. On the host side, there could be n number of possibility of attacks. One of them is buffer overflow, but there are other attacks, other threats like remote code executions or command injections. Those kind of things are also available. Application side, there are injections and there are cross-site scripting and tampering with the inputs. So there are basically n number of frameworks that could be referred when we want to identify these threats. Specifically for applications, there are Sense 25 and OWASP 10 kind of threats available. Specific to industrial control system as well, there are some threats that are given by um, IronNet. IronNet is an organization. They have identified the threats for grids, and they could be into 5 different areas. Initially, accessing the system involves crafting a malicious document and sending it through a spear phishing email. And spear phishing is a type of phishing where you target one specific person with a specific interest. So let's say I am working as a general manager in the power sector, and then the malicious sector wants to send a spear phishing email. So he would go to LinkedIn and understand about my profile and check what kind of interest that I hold. If let's say I say that I am very much interested in um, rock music, so then they will be crafting a specific email, something like, okay, rock concert is happening in India and that specific band is coming to India. And within that email, they will embed some malicious document. And when this targeted person opens that document, then boom, the system gets a backdoor and they get access to the system. Once they get backdoor, then the next step is basically to download the command and control center's malware. They get the access back, and then the next step starts. So this basically involves a very sophisticated methodology called ICS kill chain. Though ICS kill chain is not part of this particular topic, but maybe I'll show you how it is different from the IT cyber kill chain. On the reconnaissance size, basically Recce, there is a malware that is used to perform the reconnaissance, understand the system, learn about the IT and ICS network, and potentially also exfiltrate some confidential information out of the network. Then there are some network credential harvesting technique. Some of the credentials are available as well on the internet, and if the system is not configured properly, this default credential can also be used to attack the system. to make lateral movement in within your system. Let's say one substation is targeted, and then from one substation to another substation, they want to move with the threads. They generally use the methods to identify what kind of communication that is happening between these two systems, and through those networks, they will spread. Finally, there are detonation payloads. They involve targeting specific systems like your safety instrumented system, your PLCs, SCADAs, ICS, and execute the commands through the malware that is crafted there. So threat modeling basically has some basic requirements. It first requires the overview of the system. What is your system that you want to do the threat model for? It requires the asset list. We discussed about it some time back. What are your threat source? Threat source can be identified from different sources. One of them is the MITRE ATT&CK framework, which is there for ICS. Vulnerability assessment is another method. Then we really need to understand what could be the scenarios when somebody really want to target us. Then there are risk assessment methodology, some security controls, and some continuous improvement to the overall process of threat modeling. So this is a purely a literature exercise. When we do the threat modeling, there are a few things that we need to understand that how to represent that on paper. So when you are doing the threat model, there are these different elements or symbols are basically used. A rectangle box is used to identify an entity, which could be a user, a device, a program, which is outside your control. The examples are HMIs, computers, applications, and PLCs. The arrow, both side basically shows the communication. A circle basically shows an application that is running. Then two parallel lines shows storage, and a dotted line square basically shows boundary or trust boundary of that particular application. So at the end of the stack, I have one example, and there you would be able to correlate this different entity elements which are there. So there are different methods that are available in this particular site from the Carnegie Mellon University has actually listed 12 different methods, but the three methods that are highly used for threat modeling is the STRIDE model from Microsoft. And the feature of this model is it's pretty easy to use, and it helps in identifying the different mitigation techniques that could be useful to us. It's a most mature technique, and its drawback of this is it might take a lot of time when you are doing it. Then we have PASTA, process of attack simulation and threat analysis. It has its own advantage of using. One of them is it encourages the collaboration between different stakeholders which are there in your environment. The third one is the TRIK. It's a risk-based approach, and it has some automated component built into it. But one of the drawback is it has insufficient documentation available how to use the model itself. So we'll talk specifically about STRIDE. STRIDE basically means S means spoofing of an identity, and this can be used to violate the authentication into a device. Let's say you are spoofing a username, so you're basically spoofing the um, user access to your system. That I am someone, but I'm actually not someone. I'm somebody else. Then the T stands for tampering with the data, and it violates your integrity. So what if the data that is coming from your substation about the current situation is incorrect? The grid will understand, okay, this much of power is available, but it's actually not. And this is possible specifically in the context of ICS, and the protocol that are used, either it's 61850 or the IC protocols, they are not designed with security in mind, and tampering is very much possible with these protocols if you are not using some additional method of protection like encryption. Then repudiation is basically somebody taking an action, but when you are going back and checking, the traces are not available there. Non-repudiation is opposite to it, where you can actually establish who has taken what action. And if you don't have the audit mechanism enabled in your system, it becomes very difficult to identify who has taken what action. Information disclosure directly targets confidentiality. It may be possible with misconfiguration. Somebody getting access to the system through network, they can go and check what kind of systems are you basically used if we don't close or harden our system properly. Denial of service is pretty simple. It is basically overloading your capacity and then system goes in denial of service mode. And finally, E for elevation of privilege. It's simple, like the operator getting an engineering kind of access is elevation of privileges. Yeah. So this is the stride model of one of the system. And what you see here, this dotted line is the trust boundary. This is your USB device that can be used. This is your HMI that can be used. All these circular informations are, as we discussed back in this particular slide, is the processes that are used to run the application. And these arrows are basically pointing the communication. This is your database with two parallel lines, and this is how a threat model is represented on paper to understand what kind of threat do exist to our environment. So it's a very specific exercise. It requires a time period to do. I don't think it is possible to be done today, but one very important topic that I would like to discuss now is how to use the MITRE framework to our advantage when we are doing the threat modeling. So I'll be changing my screen share. Before that, if you have any questions, I'll be happy to take. Hope my screen is visible again. Okay, so this is the MITRE attack framework, and what you are seeing is the industrial control system attack matrix. So this one has these 12 different tactics that are being used for an attack. And what you see in these rows is the techniques that are used to execute that particular tactic. So let's say an attacker wants to get an initial access to your system. So he might use one of these 12 techniques to get into the system. Similarly, once he is having initial access to the system, for executing the malicious payload, he might use these 9 different techniques. On the persistent side, persistence basically means to be there in the system for longer period of time without getting caught. He might use these particular techniques. If an attacker is having access to a valid credential account, and if you are not having a mechanism to audit that, then he would use the same username password that an original operator is using to get inside the system. Then there is privilege escalation, some malware evasion techniques, discovery of the system, lateral movement. These are the techniques that are used. Then there is a collection of data. For collection of data, he could either use IO mapping, monitor some process state, some tag information, screen capture, or maybe wireless sniffing. Then there is command and control. And this particular phase, inhibit response, impair control, and impact is the main phase where they are particularly impacting the system. And these are the techniques that we should focus when we are doing the threat modeling of our system. That what if somebody gets destruction to the data which is there? What if somebody is sending unauthorized command message to our system? So uh, when we are doing threat modeling, these 3 tactics are very, very important to understand. So I know this is kind of information overload to you because threat modeling is a specific topic. It requires a longer period of time to explain it. But we discussed about Shodan. Let me give you an example of how this all starts with when you are doing an attack. So So in this. Okay, so this is Shodan's dashboard. And when you click on explore, you see different categories. You need not to put any specific search, but you simply come here and then you click on industrial control system. And it will give you a bunch of lists, SCADA, PLC, DCS, and different vendors as well. So let's say you want to search something related to Siemens. You click here, and then it will tell you what Siemens devices are currently connected to internet and they are visible to the general public. Then you can put a filter of a country. Either you can directly type the country name here, or other way is to click on any of these lists. Let's say you click on Japan. And now instead of JP, you put IN. It will list down the 669 locations where a PLC is connected to the internet. So Shodan will have its own algorithm to detect it. This might be a false positive as well, like some of the devices are cloud. And if somebody has kept a particular communication port open, which generally is used in industrial control system, it will still detect that. Like port 102, it's a Siemens Profinet port that is used for industrial control system. But these many ports having open, it simply tells that this is not an industrial control system device, but somebody is using a system as either a honeypot or something else. So it's very important that you zero down to an actual device. And one of the best way to do that is uh, coming back to this particular area where it tells about the brand name, and then you can select a particular brand that you want to focus. So this is, we are looking at country India, port number 102, Siemens device, and we are looking open SSH. So now this particular device is having open SSH open, and we have this IP address now. So attacker will just find this information. It will understand this IP, and these many ports are still open here. And then it'll start sending the malicious traffic to all of these ports, and that's where it starts from the internet side. Coming back to the MITRE attack, there is one also important thing that is here when you are doing the threat modeling. Let's say you are working in the power sector and you have identified the vulnerabilities, you have a list of your assets, and now you want to know what should be my focus point for now. So you come to this particular website, and to understand the adversary or threats for your organization or your entity or sector, you you have a bunch of information that could be useful. So who will be your adversary? For power sector, we have lots of incident that has happened in the past. The black energy attack that has happened, the crash override attack that has happened, all of them were in the power sector. So once this one loads, I will be able to show you what I want to show. I have a previously loaded file. Is it visible? Okay, so let's say you want to know what kind of techniques that we have seen in the MITRE attack framework some time back were used by uh, one particular attack group which were targeting the um, power sector. So you come to this particular tool, you go here, and then you put on the search function, and then you select let's say black energy. You select it and it will highlight under each of these different tactics, what were the techniques that were used. They use exploitation of the remote service. They use the spear phishing element. Then for persistence, they use valid accounts. On the lateral movement side, they used remote service, data transfer tool, again using valid accounts. Command and control side, they will use standard application layer protocol. So what does this tells you is you need to protect your application and assets which could give this kind of access to an attacker. How would you do this is through awareness, through security control, through hardening, and through configuration changes. So you have the list of vulnerability. Against that, you know the threats, and now you can create a matrix. What should be my crown jewel and what should I focus more to protect my entity? Sometimes it becomes very difficult that what should be my focus point, because you can see that this number of techniques which are available in each of these tactics are a lot, and it very, very important to focus on the relevant things which are there for you. You can also filter these techniques based on the attack group that you want to understand. Let's say sandworm group. And if you go to sandworm, you select it, and then the techniques that are used by them is highlighted here. Based on these techniques, you can again design your defense. Okay, so this is what I had kept for the slide. We are almost consumed 1 hour 25 minutes. Now I'm open to the questions. Am I audible?
Yes, sir.
Yeah. So questions. I thought I'll be having lots of questions.
Sir, I have some questions because my voice is clear, na, sir? Hello?
It's very feeble.
Yes, sir, basically, I am from Hindalco Renu Sagar, and we had different mix of DCS. Suppose
Okay.
Yokogawa, Symphony Plus, and Siemens. And we are going for integration of Pi server, which is
Okay.
directly connected to our OT network. And what is the basically what is the our first step to secure our because now nowadays our system is isolated from OT, and when we are integrated with OT, what is our first step to isolate or for cyber security?
Yes, very good questions. And when you are putting an additional interface to your OT, it is one of the threat vectors. The first step that you need to identify is the use case of the Pi server that involves which all systems and what kind of data your Pi server will be fetching. So basically, in such cases, you will be having a data historian, and from the historian, you might be fetching some data to your Pi server, and the Pi server would be sending the data to your ERP server. So it has a defined functionality. It should only get the data that is required to the system. Now you need to ensure that a Pi server, when it is getting connected to the OT system, it should not have the direct access. You should put a broker server in between. All the data first goes to the broker server, and the Pi server gets that from the broker server only. And This particular broker server should also have other security controls like hardening of the communication. The Pi server, which is communicating, generally it communicates on the SQL um, protocol. So you should only enable that particular protocol. There should not be no other service open. When you are putting the access control mechanism, the Pi server will have its own credential to log in, and you put the very difficult and complex credentials over there. So the entire end-to-end requirement needs to be identified through creating risk assessment only, but these are the high-level requirement that you should ask the vendor when they are doing it. I have an example of the same kind of implementation in one of the plant. And what they have done when they wanted to do the Pi server implementation is they had put all the OT systems on single network. Because of this, what has happened? There were some Windows XP systems already infected, and this malware started traversing on the network from one system to another. So rather than giving some operational advantage, it actually has increased the complexity and security issues in the network. So you should first do the risk assessment through identifying the existing vulnerability and what threat that additional Pi server will give me when it is connected to the system. Then only you should allow it to be connected.
Okay, sir. Thank you, sir.
Akshay, if no other question, shall we close?
Sir, I have a question.
Yes, please.
Yeah, can you uh, elaborate on what is like software development life cycle process?
Okay. Yeah. So software development life cycle, or in our context, let's say secure software development life cycle, is basically starts with the requirement that you will raise first. So let's say you want to have an application for
Okay.
your environment to manage the assets in the plant. So this is your requirement that you have put forward.
Okay.
Now, after raising this requirement, you would put what kind of features you want. You want a feature to automatically go and then check into different networks. And you also want a feature to include some configuration file in the system, and then it will automatically generate the asset inventory for you. This is your requirement. Once you raise this requirement, the next step will come is the designing of that particular application. How would a coder will code this? What kind of different libraries would be used? How would the front end would look like for the application? And where would you deploy the application? All those things at a designing phase requirement. Once you have designed the application, the next phase is to actually develop this application when somebody is actually coding for this using a coding language. During the coding phase, in the recent environment, there could be a number of possibility where they code and then they deploy, they test it and then come back. They again do it. It's called the agile methodology. Immediately you are sending it to the customer. They are reviewing, they are again testing and then again doing. But the typical software development lifecycle involves once it is coded, then it will be tested. And after testing only it is deployed. So till now, we had 5 phases. First, requirement, design, develop, test, deploy, and finally, the sixth phase is decommissioning the application. Let's say you developed an application, you have used it for some time, but now the system on which the application is running is no longer supported. So you need to decommission the application and then design new application. One typical example is Windows XP. You can treat Windows XP, though it's an operating system, as an application. It was designed, it was required. First, there is the requirement, they designed, they coded, they tested, they deployed, and now it is decommissioned. So that's what the software development life cycle is. Now, each of these phase in context of security would have its own security requirement. Now, security is moving. So generally, this requirement software development life cycle is a horizontal line, left to right. And what we call in security is always move left so that you can identify the security issues as early as possible. The secure software development lifecycle basically involves the same step, but you put security at every stage. When you are doing the requirement analysis, that phase also you do a security analysis. What could be my security threat? When you are designing, then you put security element. When you have coding, then you use secure coding practice. When you are testing, then you have testing application. When you are deploying, then you are again doing a dynamic test. And you are decommissioning, then you wipe out all the data which was there in the application before actually removing it from the system. I did not have a slide ready, but I hope I was able to explain it to you.
Yeah. Thank you very much, sir. But here one clarity I want. So, sir, this is like an like a holistic. We'll have like 4 to 5 servers for different applications. So in that case, if a client is giving me a requirement to give this product software development lifecycle process, so in that case, whether because I specifically my requirement is only for one specific server which needs to be supplied, database as well as front-end application servers. But in that case, if I want to provide this SDLC process server, is it to be considered only for the specific server, or I need to consider for the entire system?
No, I did not understand the question as such, like why the server are coming in picture in SDLC at all. SDLC is software development cycle, and you are talking about development servers, or you are talking about the deployment
No, sir,
servers?
because I have a requirement for Metro SCADA
Mhm.
basically. So for that Metro SCADA specifically, we are supplying for as part of PSS scope, and we have certain other servers applications running on the entire system. So that is like signaling and telecom systems and other like BMS servers. So now I have a specific requirement of providing this SDLC process.
Mhm.
So in that case, whether I need to consider the entire system of Metro process, or I can limit only to my application alone.
Yes, so you need to only focus on that particular application alone.
Okay, fine,
So
sir.
I think your question on the other side, this is basically secure development requirement for the vendor. So vendor
Yes, sir.
needs to give how are they developing this particular application. And this specifically comes into the vendor management requirement under ISMS 27000K standard.
Okay,
There are pretty much standard template available. You need to only show how are you developing and you are following secure coding standards or ISMS guidelines. That's it. It is nothing to do with the server that you are going to provide to them or the number of server that you are using, other application you are developing. It's only
okay,
about that particular application.
okay, sir. Thank you very much.
So, are there any further questions to Shiv Kataria, sir?
Sir, our question is some different from today topic, but some requirement is there. Is 64223 standards is used for cyber security. Is there any reference book or manual for 64223 and cyber security related manual?
Yes. So if you are an ISA member, so they will give you access to the standard for free. an ISA membership in India is $70 per annum. So you can get the ISA membership and then you get access to the standard. That's about getting access to the standard itself. Now, if you want specifically just to understand some part of the standard, there are n number of resources available on the internet. And I do share on LinkedIn a lot about these topics. So what you can do is you can drop a message with your specific requirement on LinkedIn and I'll be able to share some resources.
Okay. Yes, sir. Thank you.
So if there are no further questions regarding today's topic on analytic function, then we may close the session if the participants have no further questions.
All right, then. I think we are done for the day. There is no question. You can close now.
Yeah, so thank you, sir. Thank you on behalf of CBIP and all the participants for giving the lecture today on the analytic function and asset enumerations and on the other topics. So thank you, sir. That is all for class today. Thank you, sir. We may close the session.
Thank you. Thanks, everyone.
Thank you, sir.